Hello there. Welcome back to the amazing adventure of Al's little graphing program. The last one was a little bit on the technical side. I'll try to keep this one a little bit more exciting. One thing I've just added, I added several things, but one of the things I just added should help in explaining how some of this stuff works in a much easier way than I originally was going to do it. Let me see now. Where am I here? You remember my little circles thing, okay? Let me make this big. Oh, you'll notice I made this dimmer, the axes. I think it helps in seeing the other stuff. It was a bit too bright before. Okay. Now, if I had a function, what I did here is an example function, a parabola. It should work now. There's something weird. Something doesn't reset when I delete everything. This is half of a parabola. I could go from -1 to 1. The scaling here is 125, so it should go up to 125. It does. Okay. And one of the things I can do is I can make my little circles come in, and if I do toggle sprite, it's probably not going to work because I changed modes. Something doesn't get reset. Well, maybe it only works with the keyboard. Hey, let's start over again. Well, I have to be in edit mode. Was I in edit mode before? Sprite. Hang on a sec. Okay, it's not general. the sprite, I added that function, but really I only implemented it in one scenario. It does work. What happens is I'm only doing it if I'm in the vector mode and not in the polygon mode. Okay, because I wanted it to do a particular thing, which is that. So what I can do instead, what can I do in the other case? Because I don't know how to retrieve. I could save off the last function that was added or something. How do I do that? Well, okay, well this works. I'll just show you. In the vector mode, what I do in this case, I toggle the sprite. I draw a line perpendicular here, and I let the sprite walk along the line. See? Now what I wanted to demonstrate was one thing, which is what if I what if I let the position of the sprite thing be, instead of following along this one line, if I add a second line, I want its position at any time t to be the sum of the two vectors. So if I added a oh, no, not that. Make a different color. If I added another line right there, oh dear. Hang on a sec. Not that line. This line? Oh, okay. What I had before. And what I did there before was just do it a different way without the sprite. So that's one line, and suppose I added another line like this. Then I want the sprite's position at any time t to be, let's suppose, at time t. What color did I just choose? Something. One thing I did with the groups thing, I knew those groups would come in handy, is I gave the different groups Z order. So now I know the dot is going to go on. Line has the lowest priority. The dots will go over the lines. So suppose at time t that this is where the position would be of that sprite if it were following one or the other of these lines. But what I want its position to be instead would be this plus this. So its position would be this. You see? We should make that bigger. So one line. That's not a good color, is it? No, it's good enough. So one line here, and another line, this color, something. They're not, supposing they're not the same length. This one parallel, this one perpendicular. And then at a given time t, if it were following this line, it would be here, and this one, since the speed is proportional to the length of the line, turns out, in this case, because these lines go from t equals 0 to 1, so it takes the same amount of time to traverse either of these lines. Then I want the position of the sprite to be the sum of the two vectors. So it's not very good at choosing colors, am I? Red, not red. Yeah, red. Okay, red for here. Suppose that's would be its distance along here. And, green. I don't want them all to be the same color. So green its position over here, and so its end position should be the sum of those two. So if I just move this green one to here, so make that parallel, then its position in the end will be in white here, that dot. There. See? So that's not hard. This thing is becoming easier to use with the ordering now. Okay. Alright, now it turns out what I'm doing in code here, if I get the toggle sprite message, I make a line, a unit vector parallel to the last two points that were clicked, so that's parallel to this thing, and then another one perpendicular, so that would be this way. Now decide on some. Well, first, what I just showed you is I made it 200 long, right? And I added that line to just for visual, just to visualize. I don't need to add it. And then I'm adding the sprite in, and I gave it a new constructor which takes a function. So, it has a function member. It gets the range of the function, right? And splits that up into 100 pieces, and then computes its point with this function, new function I needed, which will take a position on the graph and change that into a screen position. Okay, so the point position of the sprite will be along the function's position at any given time. I added another. Now, how is he getting updated? I added to graph the graphing object a thing for sprites. Do I add the sprite here? No, on the toggle message I add the sprite. I can add a sprite to a graph, so it's not even included here, but the update, here we go, yes. Update is a function that is called once every 40 milliseconds, I think I set it at. So here's the update sprites loop. I can add as many of them as I like. And the way that works is just using a WM timer somewhere in here. Right, something timer. Here. Okay, so if I add sprite, I'm adding it to one of those groups. Find the group and add the sprite to the group so that it will be aware of it. I've got to put it somewhere, and then I set a timer. Okay, now when the timer message comes in, I just walk through all the groups calling this update function, and all that does is walk through its list of sprites if it has any, and call update. And that's a virtual function, obviously. So in my special circles thing, this is how it handles the update message. It takes whatever it took, it remembered as its starting value of the parameter, and adds some increment, and the increment was worked out in this case as 1/100th of the distance. Right, when I think it's still in here. Draw, no. Okay. Let's see now. Yeah, here. The increment is in terms of the parameter, not the function. It doesn't care about the function. It could, I mean, I could work it out by distance, but I'm just taking the range. Total range is the function parameter, and that's how much to add each time. And one of the problems I had was, originally I was doing this repositioning during the draw, right? Using the draw callback as a time to update position. But I can't do that because moving the object invokes a draw, so you end up with a recursion and then it crashes. I don't know what I've got this 3300. I don't think we need that. This is fine as it is. And you saw that happen. If I clear this out, let's see. There's something wrong I've got to fix. Something gets out of sync. I've got data duplication all over the place and I have to repair it all. But that's okay, no problem. We'll fix it later. So that's what I did here. I got Control T, and well, I didn't get my spray. Well, maybe it doesn't. Oh, probably doesn't work in full. Close. No, I got the line. No, why is it not working? Probably again something to do with either overly initialized, or not uninitialized variable, or full screen or something. I don't know. It should work this time. It should always work, but let me just see. First, if it works here. Okay. If I just switch to full screen, I don't see this bright. No. Now what if I just do this? Nothing. Oops. Do this. No sprite, I see. So it got turned off and it never turned back on again. I just want to see if I do it initially full screen, will it stay? I mean, will it work? I prefer to do it full screen. Yes, okay, that's good. So it's moving along this line, and what I want to do now, instead of it moving along one line, essentially, is I want its position to be the sum of two lines. So I added, and this is great because it means now that I can do any kind of operation I want. I added to my TS function an operator plus, believe it or not. So I'm going to make the second line, and I can put them on, I can draw them. I don't have to draw them, as I said. Turn that off to prove it to you. So I'm going to have two lines, line 1 and line 2. And I can add these functions. I can add any two functions, believe it or not. And that makes a new function, which hasn't been predefined, but has now become part of the set of functions. This first line is what I originally had, the white one. Now I'll make the other one a different color. I'll make them different colors. As I had. But I want to keep things the same. So white and light magenta for the second line. Now I'm adding the sum of those two functions, and they're different lengths. One is 200 long and parallel. The perpendicular is 200 and the parallel is 100 long. I'll just show you that working. So I'm showing you how the effect of adding two functions together, and the position of an object if it were the sum of those two functions. Make it full screen. Hopefully this should be okay. It's best if I go here, turns out. Okay, now you see what's happening. It goes a bit too far for some reason. It really should be stopping at exactly here. Oh no, that's not true. It's going as far as the sum of these two can go, right? So that is the final position is not at the corner of a box, right? But it's where, oh yeah, it is at the corner. It's at the corner of a box. Actually, I want that color. It's more of a whitish color. There we go. If I take this vector, right, and add the endpoint, well, I'm taking this vector, oh, not that color. Well, essentially, I'm taking this vector and adding this vector, right? That should be the light cyan here or something. And so its endpoint is the sum of those two. So that's where it should stop. It's almost exactly that. Right? Is that true here? I'm thinking of this parallelogram rule. Does that look like a parallelogram? Yeah, that's a parallelogram. That seems to go quite a bit further though. It goes more to here, but this might not be perfectly perpendicular. Maybe this is perpendicular. Parallel to the red one. It must be here. Oh, not in there. That's not where I clicked. Well, there seems to be a limit. Oh no, I can see, I see this thing's getting in the way. Maybe 200 is too big. Smaller. 150. When I move them, it doesn't seem to add right. There might be a problem with my addition, but you can see that the addition is working. It might be that I need to make an adjustment. Well, actually, I'm so stupid. No, the other, it is 200. I could have made it, I should make it exactly the length of this thing, then I can adjust it however I like. I'll do that next. So here to here. Alright. Let's see. This. And lastly, I'm going to try and draw this as close as parallel to that thing as I can. Just by inspection. That's correct then, right? So its final point. This is some of those two vectors there. Okay? Alright. Now I'm going to do something else. I can do this without having any sprite. Okay, you see this parabola, right? I'm going to delete it. What I want to do is rotate this by 45 degrees clockwise. Okay. Now what I want to do is I'm going to make that sprite move along this parabola, a parabola just like this. Without adding a parabola, without using a parabola. And the way I do that is I've added another new thing to modify a function called substitution of variables. Variable substitution. I can make another line. First, I won't add the sprite. Not add the sprite. Well, that's easy enough to do. Just change this full screen, and you'll see that this line, what I've done here is I passed in a function. How this works. This is a thing that changes the t variable. Okay, so I have a function that takes a double and returns a double. Okay, so like for instance, if I want to use t squared, which is I am in this case, I pass in the squared function, and this new function, whatever the function is I pass in, instead of using t, we'll use a function of t. So that's like a variable substitution for t. Okay, that's the function I chose. All this does is return x times x. Okay, so I'm going to add line 2a. Initially, I won't add the sprite. I'm going to show you that line 2 and 2a. In fact, why don't I make this a temp? I'll call this line 2. Still, I'll just make it temporary. And line 2 will be constructed from temp and squared, and then I can set its color the same, add it the same. So now I don't have to change these bottom lines when I add a new thing. So all this part can stay the same. So I make temp, and then I make a new line from temp called squared, and add the 2 to the graph, and I won't put the sprite yet. I'll ignore that bit for now. So I'm just going to show you it's going to look the same, because it turns out that these line things use a variable t that goes from 0 to 1. So as far as t squared is concerned, that's still 0 to 1. So they'll be the same length as before. I can make it longer, but it won't be in this case. Now you'll have to trust me at this point. You can only trust me that it's using a special modified variable. Come on. And this is how we can make funny motion. I was going to change the other thing. Okay, I do T, and there are the two lines. Alright? Now there's no way for you to tell that this is any different from the last one. Right? In terms of visually, it's the same. Correct? Alright. Put the sprite back. The sprite, or as I've set it up here, the sprite is its position is a function that is the sum of the two lines. Is the sum of the position at line 1 plus the position at line 2 at a given value t. Come on. I could make it just follow line 2, but anyway, you'll get the idea. If it's a great big long line, it's a lot easier to see, but it speeds up as it goes along. So I draw my line and do this. Okay. Now that sprite is not following a straight line, it's following a curved line. The curve Well, it's not this parabola, but it's similar. It's almost this, it's partly, approximately parabolic. Really, it should be this, because this is t squared, and this is t, and this is t squared, and I don't know why it's not exact. It's close. So now you see how you can make curved motion of an object, not, without using any curved function, but just simply making the parameter move, increase at varying rates, and the direction. Oh, I see. Well, I know why it's not exactly that. It will be exactly this if I make this the same length. Because remember I said that these both go from t equals 0 to t equals 1, right? And so the increase in speed, the speed of a thing along one of those lines is proportional to its length. If I use the same length line, it should follow that other parabola exactly. Because those lines will now act like axes, regardless of the actual number, whatever it is. If they're proportional, if they're exactly proportional. Okay, now my parabola. See? Now it's following this parabola because, well, it's almost slightly off, but because these lines, although it doesn't appear to be true, are the same length, 150 units long. And what we have is velocity t in this direction and t squared in this direction, whatever that happens to be. Okay? Now, I'll just show you how the substitution works. I don't know if it'll take me there. Now, all this does here is it makes a new function, and the position is determined given a variable, which is not a number but a function. It takes a double and returns a double, and the position is given by the function position, right? All of these have functions, and instead of using s for the position, I use g of s. So this is, f of g of s for position. Typically, here's how the sum works, okay? I can't just add two TS functions together. The function can't be implemented inside TS function, because the TS functions don't implement their own adding, right? They have something called an I function that the position is retrieved from. So the addition has to happen at the level of the I function. So all I did was make this I sum function, right, which is a TS function, which adds two functions. And then to implement operator plus, okay, I create a new iSum function from this object and func passed in. So that's operator plus for TS function. No, I guess so. I guess that's fine. It doesn't modify the function it's being added to, because this creates a whole new function, right, and passes that back. Just like when you make operator plus for TS string or something, right? That should be const. It shouldn't modify the object. If you want plus equals, which I could also make, then it would modify. What I would do, I could do that right now if I wanted. I could add that. This one I don't need to refer to any special new structs. This can be done entirely in here. Operator plus equals. It has to return the current object, right? And it's not const function. Now I could just implement it this way. Like that. The left-hand side will be returned. This produces a whole new function, but then I assign that to myself, and that should work. Let's see if it works. Line. Okay, line 2 is this. Okay. And then I could say line 2 plus equals a substitution of variables. Line 2 is squared. See if that works. Then I don't have to, then I've gotten rid of a variable, a temp, because I can just do this on the stack. So you see that these, what I mean by these intrinsically polymorphic things here. Oh, two. In that they act, you can use them just like you use, an integer or something. So it's now starting. These objects are taking on the appearance and feeling of just like an integer variable. But remember, these are functions and have many values, right, in the xy plane, and you can use them just like you use an int. Hopefully this works. It should work. There's no reason why not. I mean, everything's following the correct rules. I know that this statement is fine, right? Because I know that I can declare these things, and they automatically destroy themselves when they go out of scope. But by this line, the temporary created for this should have been killed. Oh dear. Oh no, it worked. Oh no, it's different. Oh yes, yeah. It's not the same as before because I changed the length of this. No. That's plus equals. Okay, that's true. Line to 150. I should have added line. No, this is not the same. This is obviously not line 2, line 1 plus. I'm sure this is right? Like this here is a line of equal length, and I've added it to itself, which is not the same as what I was doing before. Line 1 plus line 2, right? Well, that's what I wanted to try and do. I say line 1 plus equals line 2, and then just pass line 1 to the expanding circles. I see. What I do is that, and I can't really draw them, but I just passed line 1 in. Line 1 now has been modified. It's going to be, what's it going to look like? Is it going to be a parabola? It's not going to be a line. Can't be. Yeah, sure it could be. I don't know. That's right. It's not a line. It's changed its type. It's no longer an I vector at this point. I could add the first line 1, save it off. Let's see this for a minute. I'm very curious to see if I get a parabola for line 1. Take a straight line and I'm adding to it this other straight line that behaves differently in terms of t. That's right. Wow, okay. So you see how I've created a parabola function using just lines. I don't need the parabola function to make an I function that is a parabola. All I needed is for these 2 lines and this modification to the way that the t variable is used to draw, would be used to draw this temp line here. This doesn't this doesn't live forever. Let me see now. How can I get rid of line 2? rotate minus 45. Just want to see if I can do it like this. Oh no, but that rotates line 1. I would have to make a copy of it, but I can. That's non-cons. Make a copy of line 1, rotate by minus 45, and use t squared, and create a substitution of variables all on the stack, add that to my original line, and I should end up with a correct one. Oh dear. Oh yeah. Doesn't take one argument. Alright. This has this rotate had a default. Oh, because it's one of those Boolean things, I made it, you have to be explicit, so that the next person that looks at this line knows what this false stands for. About origin means if it doesn't make a difference in this case. Oh dear. Convert all of the argument types. Oh, rotate doesn't return. Oh, it should return the function. I wonder if we should recompute this. Doesn't matter. It doesn't matter. It doesn't matter because this is not the object that will be this thing params change has to do with computing the range, and every new object starts out with this being equal to true. So the range will be recomputed whenever the first time it's asked for. And all these functions move, set, offset, and so on should return reference to the object, just like plus equals, right? Just as you do with TS string. Any kind of object that's just a regular old object that has, that can be copied, that has a copy constructor, copy operator, and so on, should return references to themselves when they're modified, and then you can compound things like I do with TS string. Of course, it probably won't work. Then I got a straight line. Oh well, that's too bad. I want to make a function on the fly that's rotated. Okay, well that doesn't, I don't know why that doesn't work, but I'm sure that it wouldn't be very hard to Oh, wait a minute. No. Sure, it wouldn't be very difficult. Difficult to do. Line 1, line 2. This is what we had before. Right? I'll try and figure out why that doesn't work, because really, in theory, it should have worked. It should have returned the object in the rotated state and not modified like that. That's why this has a ref here, right? So that the angle and everything should be copied when I pass that off by reference it doesn't matter, by value or by reference should work. Oh, line 1. Oh, I see. Oh, no, that line 1's already been modified. Right. But I couldn't use itself for some reason. Oh. Well, of course, it shouldn't have been 45 degrees. It should have been 90 degrees. Minus 90. But still, that ended up as a straight line. Not sure. But that's pretty cool. And I've used too much time. On the next one, I'm going to do these things. I'm going to be looking at now the way that technique is used in the case of these Fermi curves. Here's like the first one. What I've plotted here is the function and its derivative, right? What's important in terms of the motion of something that's following a line is that we have a vector, and this is a modification, a g. This is a g, right? Substitution of variables, and the curve that's followed by an object with a variable substitution like this is going to depend on its derivative, right? How quickly this s is changing with time. At t equals 0, it's flat, so it's not going to be moving very much at all. But later on, it's going to move quicker, right? To some maximum value, or minimum in this case, and back to 0 again. And that the other point, there's 2 points involved in the Hermite curve. The second point follows a trajectory that is given by its position multiplied by with this change of variables. And the whole thing, the other two are modifications to another straight line by another variable substitution that has to do with the tangent. Anyway, next time, and I'll explain it and you'll see how it works. See ya.